Yeah, recording is on. So today's the basically session is on frequency distribution and chi-square test. All of you have SPSS software with you?
Yes, sir.
Yes, sir.
Anyone here without SPSS? Because this is a hands-on training program. So I think all of you have SPSS, right? And all of you got the data set I am given to you. 3 data set, 2 data set basically. One is SPSS file and one is Excel file. All of you got this?
Yes, sir.
Yes, sir, but not same right now.
Yeah. So you just download from your mail.
Sure, sir.
So these are mixed people who are from economics background here.
They are not in the
Can you
list.
please-
They will join later on.
They are not yet joined. So who are from geography?
I am from geography background, Tanus
Yeah,
Chakraborty.
don't see. So only one or any other?
Please tell.
Yes, sir. Myself, Manuspal from geography.
From geography, Tanushree from geography. Anyone
Sir, I am Devlina Khoshal from Geography.
from geography? Fine. So anyone from nutrition? Just the other told me.
Yes, sir.
Yes, sir.
Mohammad Atim.
So you are from nutrition.
Yes,
Yes,
sir.
sir. Me
And
also.
Mansi Shukla is from nutrition.
Yes.
Yeah.
I'm from home science and science.
Pardon once again?
Home science and science.
Home science. Fine. So basically, today we discuss about chi-square test, how to, when you solve or when you use chi-square test first, and then with the help of SPSS, how you can solve the different hypotheses you form for your research. So before starting to the basic regarding the chi-square statistics or chi-square test, I say something about the research, then I will go on the chi-square test. I will take not more than 10 minutes. As I think that if I say this part, then it is clear to for all of you to, when you do your research, to decide when you do what type of test. Is my screen is visible to you?
Yes, sir.
Yeah, fine. And for today's class, I am not showing any PPT to you. For tomorrow's session, I will show some slide, but from today, there is no PPT. Those who are interested, once recording is going here, but if you interested, you can write the thing I am written here. So when we do our research, we basically deal with 2 types of data. One is primary data and another is secondary data. For the time being, if we consider that we do our research with the primary data, in present time, if you go to the different good journals of your domain, you see the maximum papers are using primary data. there is a limitation in secondary data for fulfilling your research objective. If you use secondary data to find out what are the loopholes in the particular area, what are the parts that are not covered with the already collected data. So there is a arch for collecting new data, that is the primary data. And when you do the primary, when you try to collect the primary data, in that case, you have to make a questionnaire. And when you make a questionnaire, there are different methodology. One workshop can be done on questionnaire making part. I'm not going to the details of that part. But you remember one thing, when you make a questionnaire, every time when you set a question, in your mind, you must think about the scaling of that particular question. That is, a scaling technique is there. Generally, there are 4 types of scaling. One is nominal type of scaling. Second is ordinal. And basically, third is scale. We can divide scale in 2 parts. I will go on later. But basically, when we use this nominal type of scale or ordinal type of scale, it actually gives the birth of categorical variable. Categorical variable. And generally, when you use a scale, in scaling technique, we use the scale type variable. This gives the, in return, the continuous variable. So in maximum time, when you do our primary survey, in 95% time, the data generated from that is basically a categorical data. Why? Because in every time we try to find out some satisfaction. Sometimes we try to collect the demographic variables. When we try to collect the demographic variables, suppose age, gender, marital status, religion, social caste, it actually generates the variable of category nominal. This category. When you use the Likert scale or 5-point Likert scale or 3-point Likert scale, in that case, we use basically the ordinal scale. What is the basic difference between nominal and ordinal? In nominal scale, only identification is there. We are identifying he is male and another individual as she is female. Or we can identify someone as general category, someone as OBC B category. But in case of ordinal scale, there is a clear rank is there. So in some case, in case of Likert type scale, when you try to measure the satisfaction, suppose 5 denotes, in any scale, 5 denotes the maximum satisfaction, or 1 denotes the less satisfaction. Or if you consider the 3-point scale, then 1, 2, 3 is there. 3 indicates the highest value, 1 indicates the lowest value, and vice versa can be happen. One in some question, 1 with the highest value and 3 will be considered as the lowest value. So in that case, we use the scale that is the ordinal scale. And what is the scale variable? When it is either it is a continuous value or it consists of a discrete value. What is the example of scale? It is a number out of 100 what you get in any examination. Your salary. But in our questionnaire, we always write salary or income in a categorical form. If you go to the questionnaire, if you download from Google any questionnaire, income may be coded as like this. Suppose 1 is less than 10K, 2 is 10K to 20K, and so on. Why? Because some belief is that if we directly ask income, anyone not directly willing to say the income level. Rather, we can, if we make the category, then he can put either 1, 2, or 3, and 4. So once again, income now become a nominal type variable, not a continuous variable. So the thing is, in maximum time, we use the nominal or ordinal type of scale when we collect data from the primary questionnaire. And also we collect some scale data. This is continuous data. That is the scale data. If you collect the scale data, the scenario is, if we collect scale data, you can, from this scale data, you can make a categorical data. But if you use the categorical variable, that is, if you use the question in the form of nominal scale or with the help of the ordinal scaling technique, you cannot make this as a continuous variable. So that's why the problem is, when we do our research, we have to deal with the categorical variables. Some categories are there, some scale variable is there, but in maximum time we use the categorical variables. But what is the implication of this scaling technique in statistics? So up to this, any problem? It is clear to all of you?
Yes, sir.
It is already known to you. It's a known part. Just like the recap of just like a serial, there is a recap in the initial part, then the main part. So what is the implication of this part on the statistical analysis? Why scaling technique is required, or it is a very much, why it is very much important? Why? Because on the basis of this technique or the nature of data, we have to fix which analysis to do for our research or to fulfill our objective on the basis of the nature of the variable. So broadly, we can, if we write a data here, basically two types of data. One is qualitative and another is quantitative. So which one is the qualitative data? The data what we are measure from either ordinal scale or nominal scale. It actually generates the qualitative data. And if we measure our data by the scaling technique scale, then we get the quantitative data. So the thing is, when we use the ordinal and nominal scale, the data is actually a qualitative data. And we use the coding technique, we use some coding technique, some code to make this qualitative data to quantitative. Say, for example, where in case of gender, what are the options? Either male or female. Either male or female. So one can tick this M or F. But when you put your observation or the information of your question in the data sheet, one can put directly M and F. So if you put directly M and F, that means you are putting the text value. That is the qualitative aspect. But in any software, when you try to do this, you have to put the value in a quantitative form. And in that case, we write this code for M and F. Someone may say we code male as 1, female as 2. Someone may be code like this, female as 1, male as 2. One can use the code 0 as male and 1 as female. So in your data set, it will display 1, 2 or 2, 1 or 0, 1. And you have a definite code sheet where you written the code, what you actually use in the time of entering the data in Excel or whatever be the any other software or SPSS directly. So that's why when you're doing our research from the primary data, this is a very vital part. The first thing is the questionnaire making. And when you make your questionnaire, you must consider what type of, suppose you set a question, and from that question, you just find out what is the scaling technique for this question. That means the data generating from that particular question, is this nominal type or ordinal type, or simply it is categorical type or not. If it is categorical type, that means your data is a qualitative data. If it is a qualitative data, then you have to decode this and you have to make this as a quantitative one. Otherwise, you cannot do anything from this data. This is the first part. The second part. The entire statistical analysis depends on this nature. It's a qualitative and quantitative. So if your data is actually a quantitative data, you use some statistical test that you cannot use for your qualitative data. Say, for example, you have a information regarding male and female, and someone tell you, please find the mean for gender, and you find mean. But the mean for gender have any meaning? Do you think any meaning? If we collect 100 observations, and from that 100 observations, if we try to find out the mean for gender, it have any significance or it have any interpretation? What do you think? If we try to find out the mean of gender?
No meaning, sir.
No meaning. So why it is a no meaning? Because this data is basically a qualitative data. So for qualitative data, you cannot use mean. So you can, if you don't use mean, so you cannot use standard deviation. So remember one thing, when you're doing out your research with a categorical variable, you cannot use mean, you cannot use standard deviation. Software gives you the value, but that value have no interpretation, no meaning. Suppose you try to find out relationship between two categorical variables. When we try to find out the relationship between two quantitative variables, in that case, we use the statistics which is known as correlation. You all know this. When we use correlation to find out the relationship between two quantitative variables, not the qualitative variables. In your basic textbooks, what is the definition of correlation? The linear association between two variables. But now, from today onwards, you remember this. What is correlation? Correlation is the linear association between two quantitative variables, or linear association between two variables which is measured by scale, not nominal scale or not ordinal scale, only scale. So for scale data, if you try to find out the relationship or the association, you can use correlation. But for categorical data, if you try to find out the association between two categorical variables, then what is the suitable statistics you use? Suppose you try to find out the relationship between gender and marital status, or gender and religion. Is there any relationship between gender and marital status, or gender? And if we suppose we categorize income like this, so if we collect data of income from like this category and gender data is there, someone is willing to find out, is there any association, relation between gender and income? So your income is now a categorical variable. Your gender is a categorical variable. So to find out the association between two categorical variables, which statistics you can use? Can you say?
Yes, sir.
Can you say anything? Which statistics you can use?
The chi-square? Can we use chi-square?
Why today's class is from chi-square? That's why.
No, not that, right?
Why not McNamara? Do you heard the name McNamara test?
No, I haven't heard.
So chi-square is correct. The test is, one of the test is chi-square. The another test is the McNamara test. I will try to discuss this McNamara test in tomorrow's class, not today. Today we basically concentrate on chi-square. So the thing is, when you use chi-square test, when your data type is categorical, that is either measured in nominal scale or ordinal scale. Remember, to find out the association, what is the requirement? The requirement is minimum two variables. Minimum two variables. And when these two variables are categorical, then you can use the chi-square techniques. But if your one variable is categorical, one variable is scale, you cannot use chi-square. So the precondition for the chi-square test is two variables must be a categorical variable. Two variables must be a categorical variable. So when you do your research with this type of variable, lots of categorical variables are there. And if you try to find out the association, in that case, you use the chi-square statistics. And when you do the chi-square statistics, the table is famous is known as contingency table. A two-way table is there. Suppose, as we told earlier, one is income and another is gender. So male, female, and some income category. Suppose 1, 2, 3, 4. Definite coding is there. So this is the two-way table. I will show in SPSS. It takes just 1 second to calculate this two-way table, two-way classification table. But what it means? It means here is the total. And here is the column total. This actually the row total. And this gives you the column total. And suppose this is 5. This is 10. This is 2. This is 11. This is 13. 20. 31. 21. 70. What is the interpretation of this table? The male and income category 1 is 10 individuals. Similarly, if we consider this one, what is the meaning of this? Female with income category 3, 31 individuals are there in the sample. Similarly, if we consider this 21, what is the interpretation? Male with income category 4, 21 individual is there. And if we put the sum of here, it is 62. 20, 20, 40, 50, 60, 62. So the total male is 62. And what is the total female? That is 20, 30, 61, 62. So altogether there are 124 observations. So if we add this, here is 12, 4, 24, 51. And if we add this, it gives you 124. So this is the contingency table. The software gives certain other things. I will show you when I show you in SPSS. So this is the meaning of the contingency table. And from this table, there is some rule of thumb. You can decide is the chi-square test is applicable or not. What is the rule? The rule is that in each cell, this is the one cell. In each cell, the observation must be more than one, number one. And number two, if the observation is less than 5 in any cell, you can also do the chi-square test. But the thing is, majority, that is the 80% of the cells, total cells, have more than 5 observations. So the minimum observation is 1. If any one of the cell have 0 observation, suppose if we make this 0, so you cannot run this chi-square test. So any cell have 0 observations. Suppose you make your contingency table and you see that any one of the cell is containing 0, you cannot go for the chi-square test. But if it is 2, if it is 2, then you can go for chi-square test. Why? Because of 80% of the cells are more than 5 observations. Clear? Why? Because when you, in your paper or in your research, in your thesis, when you write the value of chi-square test, you have also write this particular table. And how you represent this table? The most common representation in thesis is, suppose your gender is here, income is here. I reverse this table. So here is two category. One is male, another is female. Income is here, income of different categories. These are the four categories. So in your table, gender is here. These two variables. Now you put your chi-square value for this test. You can also give the significance value or the p-value. So this is the table, final table. So from software, you get everything. So you have to complete this table. So in every time, suppose we just look to gender, you use 4 or 5 variables. You have to find association with gender. So you just write gender here and write the variables names according to the income and some other variables like this, and put the chi-square value and the p-value. So this is your final output. So contingency table, you have to, in your research paper or in your thesis, it is compulsory to give the contingency table. If you give the only chi-square value, it is not accepted. You have to put the contingency table in your paper or thesis. And when you put your contingency table, you overlook this, any zero is there, and you run the chi-square test, that chi-square is not a applicable chi-square value or the accepted chi-square value. You have to check this. Clear?
Yes, sir.
The next thing is, suppose you do your test and you got 0 here, actually 0 here, not 2. You just put 0 here. Then what to do? Chi-square is not applicable according to the rule. So what the solution? The solution is you just merge these two, 1 and 2. If you merge this, automatically this is 21, this is 13, no 0 is there. So if this happens, you can also use SPSS, use chi-square test by merging two categories. So that's why there is a huge importance of this contingency table. So first you have to study this contingency table. If there is any problem with this contingency table, if 0 is there, or if the second condition, that is 80% of the cells have more than 5 observations, that also violated in some cases, then what we have to do, you know what is the classification, you according to this you merge this. But remember one thing, you merge the category, but you have to interpret this. So please remember the domain knowledge. You have to apply the domain knowledge to merge this 1 and 2. Why you merge this? What is the meaning of this particular category? That you have to decide from your domain knowledge. Clear up to this part?
Yes, sir.
Yes, sir.
Any doubt up to this part?
No, sir.
Sir, how do we decide that whether we can merge the values?
If you, in your contingency table, if any one of the cell is 0 or 80% of the cells have not containing more than 5 observations, you cannot apply chi-square. So in that case, you have to merge the categories.
Okay. Okay.
Yeah, in that case, you have to merge the categories.
Yes. Okay, sir.
Any other question? Please feel free to ask question. So all of you open SPSS. All of you open SPSS.
Yes, sir.
And open the data set GSS 93 subset. GSS 93 subset. First, I will show you how to, what are the steps, you just write down, then you will practice. The first half, I will demonstrate. In the second half, you will do, and if you face problem, you just ask me. Clear? Or any query? So, what we actually try to do here, this is the data set. All of you know this is the variable view and this is the data view. Clear? And if you go to the variable view, I think this part is covered to you, how to put data in spaces and what are the different types of scale. Is it known to you? Is it known to you?
Yes, sir.
Yes, sir.
Please respond, otherwise. So you see, this is the data set. Majority of the variables are ordinal, measured on the ordinal scale. And some scale values are there. So when we, in this particular case, one of the variables is here light. You see, is light is exciting or dull. And if you see the category, see, these are the categories. One is dull, another is routine, another is exciting. So these two are basically DK, NA, NAP. These are the missing observations. Those who are not correctly answered. So basically there are three categories: dull, routine, and exciting. Clear? This is the variable. That is, the variable is in 28, row number 28. This is the variable life. If you see, this is the life. Routine, exciting, these are given. And the beauty of SPSS is, if we click on this brush option, it gives you the numeric value. So what I told you earlier, this is basically a qualitative value. Basically a qualitative value. And from this qualitative value, we make it quantitative by coding. And what code we use here in SPSS, it is also given. Here the code is 1 is coded as dull, 2 is coded as routine, and 3 is coded as exciting. And 8, 9 are DKNA and 0 is SNAP. Right? One can say I am coding 1 as exciting, 2 as dull, 3 as routine. No issue, you can code. You can code. But you have to use this particular technique. So the objective is, so this is the perception about life of an individual. What they think about their life is dull or routine or exciting. And the another variable here is respondent sex, that is the gender. And here the code is, this is the commonly code used for the gender variable. One is male and 2 is female. One is male and 2 is female. So here the objective is to find out, is there any relationship between gender and the perception about life. So what is the objective here? The objective is, what you try to find out here? We try to find out here gender and life. These two variables, that is gender and life, have any relationship or association, exist or not. And what we see, gender is a categorical variable, life is a categorical variable. So when both the variables are categorical, we try to find out the association between these two variables. In that case, what statistics we have to use? The statistics we have to use is the chi-square statistics. Is the chi-square statistics. So what test we use? This is the chi-square test. So what is the null hypothesis for this test? The null hypothesis is no association or relationship. In basics textbook, basically the hypothesis is written in terms of association. And what is the alternative hypothesis? Alternative is just revert. Association is there. So the null is no association. And so when you use the chi-square test, by default the null is no association between gender and life. And what is alternative? Alternative is there is association between gender and life. So the hypothesis for the chi-square test is, remember this thing, the null is always no association, no relationship. Or one can say gender is independent of life. Or we can write this, variable 1 is independent to variable 2. So no association means each variable is independent. And the alternative is there is association, that means not independent. So you can write the hypothesis in terms of association, in terms of relationship, or in terms of independent. The variables are independent to each other. Variables are not independent to each other. Independent means no association. Each are independent variable. No relationship that there. Not independent means association is there. So in basic statistical books, for example, Gungupta, Dasgupta, or N.G. Das, if you go to the inference chapter, so no association is there. This type of hypothesis is framing is there. But in some new books, they are writing this type of hypothesis. Independent to variable. Variable 1 is independent to variable 2. Against the alternative hypothesis, variables are not independent to variable 1 is not independent to variable 2. That means there is association. And in every time our research, we are trying to accept the alternative hypothesis. Why? Because if there is no relationship, exists, then our research nothing tells anything. But if there is an association, then we can say, see, there is association. So why this association? We can explain. But the reverse is also true. If you do not reject the null hypothesis, that means no association is there. Then also a scope to justify why there is no association from your sample. Why this happened? Why no association is there? You can also interpret that part also. So how we solve this? To perform chi-square test in SPSS, the first step is click on analyze, then click on descriptive. Click on analyze, click on descriptive. Then click on cross tab. Analyze, descriptive, then cross tabs. First click on analyze, then click on descriptive statistics, then click on cross tabs. Clear? We just write the steps, analyze, then descriptive statistics, then cross tab. So once you click on cross tabs, this cross tab window appears. This row or rows, this actually indicates the variable that you consider in row and the variable that you consider in column. So first we select respondent 6, I think. 14 respondent 6. This one is the respondent sex. So we select in row. And life is life is like IG. His life is exciting or dull, we put them in column. First you select this. You can select more than one variables also. Now click on statistics. You just click on chi-square.
Excuse me, sir. Sex education, that we have to select.
Pardon?
Which row we have to select? Sex
Not which row, which
education.
variable. You select respondent sex in the row column and is life exciting or dull in the column. These two variables. So one you select as row variable and one variable you select as a column variable.
Yeah. That is
Fine.
row. Respondent
Yeah.
sex.
You can change this. You can change row. Life is in row variable, sex in column variable. No issue. So you have, out of two variable, you select one as a row and one as a column to make the contingency table. Click on statistics, then click on chi-square. Only this chi-square. Here. Then continue. Then click on cells. You just click on percentage. Under percentage, you tick row, you tick row column. Under percentage, you tick row, you tick column. Then continue. Under format, it's fixed as ascending. Here, click on continue. So we have only used these cells: statistics, cell, and format. Under statistics, select chi-square only. Under cells, select observed. Under percentage, you just tick row and column, then continue. Under format, by default it is selected ascending, click continue. Clear? Now click OK. So this is your SPSS output. First you see, in this case, you see all the cells: 20, 202, 204, 45, 257, 269, 65, 459, 473. All are satisfying the condition. All are greater than 1 and all have value observation more than 5. Clear? But what is the interpretation of this table? What is the interpretation of this table? The interpretation is just see percentage within respondent sex. That means this actually give you the row percentage. That means out of 100, if you consider this line,
Sir,
so out of 100 male, 4.7% are arguing that they perceive that their life is actually dull. Out of 100 male, 47.4% are in favor that there's routine life. So going to the office or college, then come back to the home, do some household work, then again go to the sleep, and again morning after wake up, prepare for the office and go to the office. So the routine. And 47.9% are perceive that their life is an exciting life. So this is the percentage of male. So from the sample, out of 100 male, 47%, nearly 48% are in favor or perceive that their life is exciting. 47.4% think their life is a routine life, and only 4.7% are perceive that their life is dull. No excitement is there, routine is not there, so kind of depressed life. Similarly, among the females, if we consider this particular line, among the females, this once again the raw percentage. That is, out of 100 females, 47.1% are actually in favor their life is exciting. 45% perceive their life as routine, and 7.9% perceive their life as a dull. Clear? The interpretation is clear, okay to you?
Yes, sir.
Now, if we consider this percentage within life exciting or dull, so this actually give you the column percentage. And if you see, if we consider this value, and if we consider this value, what it means? The persons who are perceive their life dull, out of them 69% are female and 30.8% are male. The persons who perceive their life as exciting, out of that 56.9% are female and 43.1% are male. Similarly, the persons who perceive their life as routine life, 44% are male, 56% are female. So from row percentage, you can explain the table in terms of the male and female. So what percentage of male perceive their life as routine or exciting or dull? And in terms of column percentage, that is this value, you can interpret this table as out in who perceive their life as dull. How many of them are male? How many of them are female? Similarly for routine and exciting. Is it okay? The
Yes, sir.
interpretation is okay?
Yes, sir.
Clear or not?
Clear.
Any doubt?
No, sir.
No, sir.
So the next is the chi-square test. You don't look this. We only consider this Pearson chi-square from this table. So what is the chi-square value? The chi-square value is 4.137. What is the p-value? P-value is 0.126. What is the rule of thumb? The rule of thumb is if p-value is less than 0.05, reject none. You just remember this one line. If p-value is less than 0.05, reject null. That means if p-value is less than 0.05, reject none means we are accepting the alternative hypothesis. In statistics, when we write this, if p-value is less than 0.05 or we reject null, that is actually the scenario when we say the test is significant. When the test is significant, p-value is less than 0.05. That means we reject null or we accept the alternative. So the thing or the scenario in statistics is known as the test is a statistically significant test. But in this case, what is the p-value? The p-value is 0.126. So what it means? The p-value is greater than 0.05. P-value is greater than 0.05. We are not in a position to reject null. We are not in a position to reject null. We have to accept null. We have to accept H0. What is the H0? No relation, but no association. That means from this test, from this chi-square test, we can conclude gender and perception of life have no association. Gender and perception of life have no association. If it is less than 0.05, then you can say there is association. But from this, we can say, we can conclude there is no association between gender and perception about life. Clear up to this?
Yes,
Yes,
sir.
sir.
Any doubt regarding the steps?
Sir, can you just repeat it? It will be very nice.
Which part?
Sir, who, accepting the alternative statistics test is significant when we call that p-value is less than 0.05,
Yeah, please,
rejected
please,
null.
listen. The rule is if p-value is less than 0.05, that means we reject null. This is the rule.
Okay,
In
sir.
statistics, the rule of thumb is if p-value is 0.05, in some time we can case the 10% level of significance, that is 0.1. But in general, we use this. If p-value is less than 0.05, reject null. Reject null means what I told written here, two hypotheses, H0 and H1. So when you
Yes,
reject null, that means we are accepting H1. It's
yes, sir.
variable
Alternative.
association. But
Huh.
if in our case, what we get? The p-value is 0.126.
126.
That is more than 0.05.
Yes, sir.
So the test is not statistically significant.
No, no, no.
That means we are not in a position to reject null.
Okay,
What is our
then we can
interpretation?
accept
There is no association between gender and
associate.
life.
Thank you, sir. Yes.
Clear it is?
Yes, sir. Yes, sir.
Yes, sir.
Now you import the Excel file that I given you. I think the name of the file is view underscore prac underscore sky chi. We just import the sheet 1 from the data. Do you know how to import the Excel file?
Yes, sir.
So please export. Please export that file first. And sheet 1. You just open sheet 1. All of you able to open?
Yes, sir.
Yes.
What are the variables there?
Age, gender, religion, area, vocation.
A1,
And
A2,
then
B, A3, B2, B.
Then A1, A2, A3, B3, B2, B3, G14, H1, V14.
Fine. And see, when you import your data, your all data is coded as scale.
স্যার আপনি কি প্রেজেন্টেশনটা দেখা মানে
আমি
সিটটা
প্রেজেন্টেশন বন্ধ করে রেখেছি দাদা।
আচ্ছা ঠিক আছে ঠিক আছে
Students are try to do, then I will show.
ওকে স্যার
So if you open your data, you just see in your data file. ক্লাসে আছি তো। If you go to the data view, see your measure is always here given as scale.
Yes, sir.
Is it not correct? So first task is when you import data from Excel, you go to the variable view and see the scale is properly mentioned here or not. If not properly mentioned, you just change the scale type from scale to ordinal. From scale to ordinal. Now my screen is visible to you.
Yes.
How you
Yes,
change
sir.
this? You just
Yes,
click
sir.
here and make this ordinal. Now all the variables are in a ordinal scale. And since we import it from Excel, if you use the brush option, no issue, all are the values. So if anyone interested to code this, if you already know how to code this, click on value and then code this. For the time being, I skip this part. Now, my question is there any relationship between gender and A1 to A3? Hypothesis or the object research question is there any relationship between gender and A1 to A2 and A3? So please solve this first. Gender and A1, A2, A3. What are the steps? Already you know. Click on analyze, then descriptive, then cross tab. Select gender in row or column A1, A2, A3. In if you select gender in a row, then select A2, A1, A2, A3 in column. Got your output?
Yes, sir.
All of you? Or only one?
Yes, sir.
Can anyone of you interpret this? The result? Anyone from you can try this?
Sir, sir,
First I will show
for
you the
A,
result. Just a minute. First I will show you the result. So gender, I put this row A1, A2, A3. Chi-square. Then continue. Under cell, select row column, then continue, then OK. First interpret this table. Interpret this table.
sir, for A1 category, chi-square value, Pearson chi-square value is 2.425.
No, first you don't concentrate on chi-square table.
Oh,
First you try to
okay,
interpret
okay,
this cost table.
okay, okay. Out of 100, okay.
And see the mistake you already. You do the mistake. What is the mistake? Mistake is out of 8, 1 is 5, 1 is 3, 1 is 1. So what is the 20% of 8? 1.6. 8 cells. So what is the 20% of 8? 1.6. But your 2 cells actually the observation less than 5. Less than 5. And this particular cell only 5 observations. Just 5. So if we consider this, so out of 8 cells, 3 cells have observations 5 or less. So the 25%. So it violates the rule. It violates the rule. You cannot apply chi-square for this particular table.
Okay.
And this is a part of the PhD thesis data I will show you. I will give it to you. So my request is don't share this data. So this is a practice purpose for this workshop. I will share with you the part of the data. Only 100 observation or 110 observation I will share with you and the part of the data. Similarly, if you see this second table, gender and A2, you see this table satisfy this.
Yes,
All
there
the
all
values are more than
all
5.
category is more than 5. More
More
than
than
5.
5.
Yes. Yes.
If you consider this, you see these two are not satisfying this because 2 cells have
No,
value
it.
5. Again, there is a
Yes.
violation.
Yes. 4 and 2.
4 and 2.
4 and 2. Yes.
All of you, please. It is clear to all of you.
Yes, sir.
So, what to do? We have to match these.
March.
We have to match some categories. So, from the
Yes.
domain knowledge, you have to fix this. Which category you have to match to which. There must be definite meaning for that. You cannot match less than 10,000 with more than 50,000. You cannot merge this. There is no meaning. But merging have some meaning from your domain knowledge. So in this case, we are merging this from 4 category. Out of 4 category, we are making this a 2 category. How we make this? If we see the output, 4 categories are there. In A1, 4 category, in A2, 4 category, in A3, 4 categories are there. So now, since A1 and A3 in both the cases, we cannot perform the chi-square statistics, chi-square test, what we think? We record this in a different variable by merging these categories. And how we do this with the help of SPSS? Anyone know how to create new variable from the old one?
No, sir.
No, sir.
So when you use the chi-square test, in some case, suppose anyone here from psychology or education?
Yes, sir.
You're from
From
psychology?
education.
Huh?
Education, sir.
Education. So in education, you use some different 5-point scale to measure the ability, perception, patience
Yes,
of
sir.
students.
Yes, sir.
And in that case, in maximum scale, what you do, different scaling method is there. You collect 30 observations, you add this, according to the score, you category this. The 25 to 30 is excellent, 20 to 25 is good, 15 to 10 to 20 is moderate, below 10 is low quality.
Yes.
So first we collect this type of data. Suppose this type of data, suppose this is a scale. So if we add this, we can create a score. If we add all this value, and from this score, that is from this score, we have to make the category. So first I will show you this part, how you add this all value to get a score, and from this score, how you make a category first. Then I will show you how from this A1 variable, you can transform another variable from this A1. Clear? The two part. One is how you compute a new variable from this A1 to H1, considering adding this, how we add these all values. And the next one is how, after adding, how we make this variable as a categorical variable. Once again, a categorical variable. Just like 3, 1, 2, 3, 4. Clear? My target,
Yes,
my question is clear to all of you?
yes, sir.
Yes.
So when you try to compute this value in SPSS, in Excel, what do you do? Simply equal to sum and drag the values. And all of you do this in Excel. I know that. But in SPSS, easily you can do this. And in Excel, you can only find out the sum of the observations, addition of the observations, but you cannot make the category. In SPSS, you can also you can find the sums as well as the categories. So how we do this? The first is click on transform. Click on transform. Then click on compute variable. Click on transform. Click on compute variable. Clear? So once we click on compute variable, you see one your target variable and another is a numeric expression. So under target variable, you put any name. Suppose we put the name is score. Commonly used in psychology, in nutrition also, there is a scale of measurement regarding food habit, regarding oral habit. So what we try to find out here? Addition of all this. How we put this? Just select this A1 and drag this. Then put plus. Then select A2, drag this, click on plus. Or you can select this and double click here. Automatically A3 is there. You just then plus. You can also use the plus sign from your keyboard also. Then B2, either you click here or here, double click. B2 is there. Then plus. Then B3, you select this, plus. Then you put plus sign. Plus sign. No plus sign is there. H1 is the only variable. Addition of all these. So what we try to find out, a new variable score, the numerical expression is adding all these. If you try to find out the average, From here, you can find the different functions are there. Mathematical function, statistical function. If you see max, mean, median, variance, mean is the average. You can find out the mean value of this. So if you select mean, you just see mean is there. So you have to put the only the cell reference. You can do anything. Here we only use the simple addition. And after this, you click OK. You just see this is the value. This is the value. The score value. If we try to see the fine frequency of this score value, these are the value. And from this, someone is make some category. So according to the rule, what is the categories are? Suppose there are 3 categories. Out of 15 is one category. 15 to 20 is another category. And 21 to 24 is another category. So how we make 3 categories from these values? Here, how we make 3 categories of these values? So how we make this? Once again, click on transform. Here is 2 options. One is recode into same variables, another is recode into different variables. My suggestion is always use recode into different variables. Why? If you record the same variable, the original variable is not there. Original variable vanishes. But if you use this recode into different variable, so original variable always with us. So original variable is there, retain with the data set. So use this option, record into different variables. So if you click this, here is the window. And which variable we have to, from which variable we create the new variable? So that is input variable and output variable. So in this example, score is the input variable. And what is the new variable? Score category. Score cat. This is the score variable and this is the score category. Clear? After writing this, click on change. All of you follow me, or I can repeat this step.
Yes, sir.
Yes, for which one? Repetition or continuation?
Sir, can you
So
just
following.
please repeat? Thoda
Please
sa.
repeat. So click on transform, record into different variables. Click on this, select the variable, that is the input variable, from which variable you are trying to create the another variable. So in SPSS, this is the input variable and output variable. So input variable is here, score. Click on score. We try to find out the categorical variable from this score, make some category. So name the variable as score category. Score category. Clear? Then click on change. Then click on old and new value. Click on old and new value. So first is, what is the first we consider? There are different options. You can put single value, you can put range lowest to value, range value to highest, all other value, different options are there. Here we using the concept of range. Why? Because we are considering here 0 to 15. Put 0 here to 15 here as category 1. 0 here to 15. Put 1 in the new value box. Value is 1. And you will click add. So 0 to 15 is now coded as 1. Next is 16 to 24. 16 to 24. We code this 2. 16 to 24, we code this 2. Next is, sorry, not 24. 16 to 20. It is the option change. Just change this. Next is 21 to 30. we code it as 3. We add this. What we do here, we use the range here because according to the structure or the scale, 0 to 15 is coded as 1, 16 to 20 is coded as 2, 20 to 30 is coded as 3. In maximum standardized scale that is available, some in those are from education field or psychology field, you know, this Agra scale is there. You use this, you buy this from Agra and use this scale, and in this scale this type of categorization is there. So once you first make the score, and from this score with the help of SPSS comment decode into different variables, and which is available in transform menu, you can create this category. So once we continue, click continue and click OK, you just see the new category is created. According to this, you just see 21 more than 20 is 3, 19 is 2, 9 is 1. Suppose you think is this category is actually corrected category, we do it correctly, cross check this, make the frequency, descriptive, cross tab. When you use this type of data, cross tab is a huge implication. You just see 1, 2, 3. You just see in 1, 2 and 3 is 0 up to 15. Just see this up to 15, 2 and 3 is 0. So all the categories up to 15 score, we already coded this one. So right click code it. In case of 2, you just see 16 to 20. Only these observations are positive, all are 0. So up 16 to 20 is coded as 2, right click coded. So by default, the category 3 is also right click coded. Now I think it is easy to understand. You just see for one category 1, these are the observations. See up to 15. But all these 2 and 3 are 0. So we coded 1, that means below 15 is coded 1. Similarly, from 16 to 20, you just see this category 1 have no observation, category 2 have no observation. So means this 16 to 20 is coded as 2. Similarly, 21 to 24 is coded at 1. Clear? And see the significance level in chi-square is 0. That means you cross-check this. There is a clear association between score and score category. Although this is a wrong chi-square. Why? Because this score is not category level. We make this, from this score, we make this category. Now, if you try to analyze the relation between gender and score, what do we use? Just simply put gender here. You see, still there is a problem. Only 2 is there. But all other cells are more than 5. You can go for chi-square. And what is the rule? P-value 0.314. That implied we cannot in a position to reject null. So there is no association between gender and score. It is clear?
Yes, sir.
Is it clear or not?
Yes, sir.
Next is how you convert these variables. We already put this category. How we change this category? The option is same. Click on transform, decode into different variable. You can reset. Now the input variable is A1. I am writing here A1 new. A1 new after new category. Clear? What is the old and new value? Here we put first the value as 1. And we write this 1 as 0. And all other values 2, 3, 4 as 1. What do we do here? We put 1 as a 1 category and 2, 3, 4 as other category. So 1 is 0 and else is 1. How we do this?
Sir, can you repeat, please?
Yeah. I put 1 here. Value is 1. Now the new value is 0. So the old value is 1. So in A1, the value is 1. Now it is recorded as 0. And all other values. A1 new, change this, old and new value, 1, the value is 0. And all other values, just see here is the option, all other values. So except 1, all other values, we are coding as 1. We add this. Then continue. Then click OK. You see? Now the values are 1 and 0. Under variable view, make this as categorical, ordinal. Clear? Make decimal 0. So A1 new is created. By the similar fashion, you just create A2 new and A3 new. Similar fashion, you create A2 new and A3 new. That is 1 is equal to 0 and all other values are 1. We just make this for the variable A2 and A3. Are you enjoying or feeling bored?
Sir, I could not understand.
Which one?
This one, new A1 to A1 new. Can you
Just
please
like the
repeat?
before. Are you understand this part from score to score category?
Yeah. What?
From score to score category. Are you understand
Yeah.
this?
It I have done, but in A1 I have changed that from A1 to
You just see. I just repeat the steps. The steps is same. Transform, then decode into different variable.
yeah.
This is the value.
Yeah.
A1 is the initial value. We created the new value. What is the old values? What we written here? You just consider this one, then it is clear to you. A1, 1, 2, 3, 4. A1 new. What do you do? 1 is coded as 0. And all 3 is coded as 1. Similarly for A2 and A3. So what it means? The value coded as 1 in A1 now is coded as 0. And all other values 2, 3, 4 is coded as 1. So how we do this? We put in with a value. We put 1. And the new value is now 0. We add this. And all other values, that is 2, 3, 4, is now treated as coded as 1. So all other values is coded as 1. If we add this, so now there is 2 category. One is 0 and another is 1. We continue this and click OK. A1 new is created. Right? By the similar fashion, similar method, You just calculate A2 new and A3 new. You just calculate this first. All of you able to do this? Are you created A1, A2 new and A3 new?
Yes, sir.
So now try to find out the relation between gender and A1 new. Gender and A1 new. Same method, cross check. We just replace this, and the A1 new is a new variable. First we make this as ordinal. So analyze descriptive cross steps. See the value. Here the chi-square value is 2.024153. See, initially when we run with respect to the variable A1, see what is the chi-square value? 2.425. Significance is 489. Now see the value is 0.153, and the chi-square value is 2.042. So once you change category, automatically by the definition of chi-square, I am not going to the mathematics. The value changes, the significance value also changes. So the another manipulation, I quote unquote, you can do when your statistics is not significant. So you can merge the group and try to make it significant. So it is 0, 1. Suppose it is not significant, so make it for 0, 1, 2. Make 3 category and then see what happened. If it is significant, then you can write something according from your domain knowledge. So similarly, you can see you can run for A2 new and A3 new variable and see what you got. You just run for the similarly gender and A1 new, A2 new and A3 new. Similarly, you can try to test the hypothesis that this A1 new have any association with the age have any association with A1 new. Perform the chi-square test. Age and A1 new. Is there any association between age and age and A1 new? Consider two variables, one is age and another is the variable A1 new you already created. And say what is the result. Is the statistical test is significant or not? What is the result?
1.38
Which one is 1.38?
Pearson chi-square.
What is the significance value? What is the significance value from your test?
0.05.
0.05. But if you go through the contingency table,
Yes,
Chi-square
sir.
test.
There are three values, which are 2 and 0.
so 0 is accepted.
No.
What you
No,
have to do?
we can't.
Once again, you have to merge
Another.
the age variable. So now create new variable age new. And in this case, what we have to merge? The initial age, that is 1, 2. You just merge 1 and 2 as one variable and 3 as other variable. 1 and 2 as one variable and 3 as other variable.
Sir, in age.
In age.
Okay.
So transform, record into different variable, reset this, click age here. Now name this age new. This is actually research. You have to do the analysis with the data. With the help of software, it is very easy, but it is not so easy. So on one click, you got your result. You have to run different time to get your final result, final output. So what we do here? We are putting here 1 through 2 as 1 and 3 as 2. 1 through 2 as 1 and 3 as 2. And then click continue. Then click OK. Now if you perform, before that you make this categorical one, ordinal, analyze, descriptive, and cross tag. Change this by age new. Click OK. So now the value is 0.113, but the significance level is 0.737. So age and the variable a1 new have no relationship. We are not in a position to reject null. We are accepting null. That means age new and a1 have no relationship. Clear?
Yes, sir.
So now we do it for occupation. You just see another variable is occupation. You just do this for occupation. Clear? Here also you see this cell, two of them have less than 5 frequency. But how many cells are there? 12 cells. So 20% of 12. So merely it also violated because 2 threes are there. So we have to record this occupation. So that's why in times of questionnaire framing, the rule is don't give too much options. Give limited options. And with limited options, try to collect your information. Because when you collect this type of data, occupation data, so merging of occupation data is very tough. You can merge age category, you can merge income category, but you cannot merge occupation. You cannot merge the religion type. You cannot merge the social caste type. So the thing is, you have to collect the data with limited options. And this is the small case, the sample size is only 118. So that's why in primary survey, if you collect more data, then automatically this type of problems do not arise in your data set. So if you do it with the 400 observations, then you see all the observations are more than 5. Since this is the limit, the sample size is small, only 118 samples are there. So this creates this types of problem. So if you do your research with a more sample size, if it is large, then you can overcome this type of problem. So any doubt up to this part?
No, sir.
So are you now able to run chi-square test and interpret contingency table?
Yes, yes, yes.
Yes, sir.
So are you feel bored or enjoying this session?
Enjoying. Good.
Very informative.
So today we stop here. Tomorrow we will meet at 5:30 with non-parametric test. And the chi-square today we do that also of example of non-parametric test.